Alright, hackers and hackerettes, welcome to a new video in the TryHackMe Network Fundamentals Pre-Security course, or walkthrough, or I don't know, labs. Anyway, call it whatever you want. And if you have not been following along, I do recommend that you do and go watch my my playlist for network fundamentals in TryHackMe Labs, because they are building on top of each other, and it is recommended that you get the entire details in sequence. In this video, we are, like in the previous video, we talked about LAN fundamentals, and then we're moving on to OSI model. The OSI model, or Open Systems Interconnection model, is an essential model used by networking. If you're getting annoyed by this, I'll just move it off the screen here. Used in networking, this critical model provides a framework dictating how all networked devices will send, receive, and interpret data. One of the main benefits of the OSI model is that devices can have different functions and designs on the network while communicating with other devices. Data sent across a network that follows the uniformity of the OSI model can be understood by other devices. Okay? The OSI model consists of 7 layers, which are illustrated in the diagram below. Each layer has a different set of responsibilities and is arranged from layer 7 to layer 1. At every individual layer, where are we? At every individual layer that data travel through, specific processes take place, and pieces of information are added to this data, which is what we'll come to discuss in the upcoming tasks within this room. However, for now, we only need to understand that this process is called encapsulation and what the OSI model looks like in the diagram below. Okay. So we have applications. So it goes from layer 7 to layer 1, like the deeper we get. So we have apps 10BD or 10DB, apps 10DB, application, presentation, session, transport, network, data link, and physical. So apps 10DB, if you want to memorize them, apps 10DB. So application, presentation, and then session, because I forgot it already. And then T is transport. And then N is network. And then the D, apps 10DP, and then the D is the data link, and then the P is, of course, the physical. So if you want to memorize them, like try to study them, apps 10DP, and then just try to memorize them, because you're probably gonna need them, or like if you're in a networking interview or cybersecurity interview, and they ask you about the OSI model, you are expected to know what these are, and maybe not necessarily memorize them, but at least like memorize what they are, what they stand for, and all of that cool stuff. So application, presentation, session, transport, network, data link, and physical. So what does OSI and OSI model stand for? It is open. If you don't know what this is, it is mentioned right here. Open Systems Interconnection. Interconnection. Okay. How many layers in digits? There are 7 layers. What is the key term for when pieces of information get added to data? If you don't remember, it's encapsulation. And let's get into the layer 1 physical. So we're starting actually from the very lowest to the highest. So layer 1 physical. This layer is one of the easiest layers to grasp. Put simply, this layer references the physical components of the hardware used in networking and is the lowest layer that you will find. Devices use electrical signals to transfer data between each other and in binary numbering system, 1s and 0s. For example, Ethernet cables connecting devices such as the picture below. What is the name of this layer? Do you remember? Yes, you're correct. It's called physical. What is the name of numbering system that is both 0s and 1s? Of course, we know this by now. What is the name of the cables that are used to connect devices? Ethernet. I don't know why this one doesn't have dashes. Anyway, so this is our physical layer. Let's get to the data link. The data link layer focuses on the physical addressing of the transmission. It receives a packet from the network layer, including the IP address for the remote computer, and adds in the physical MAC, like media access control. If you remember MAC address from the previous video, please watch the other videos if you haven't, because this all just builds on top of each other. Of the receiving endpoint. Inside every network-enabled computer is a network interface card, or NIC. You're going to hear this word NIC a lot in networking, which comes with a unique MAC address to identify it. MAC addresses are set by the manufacturer and literally burnt into the card. They cannot be changed, although they can be spoofed. So be careful of this. While you cannot like go in and physically change them, you can actually spoof them. So kind of the same thing. But overall, if you're not spoofing, you cannot change the one like permanently. When information is sent across a network, it's actually the physical address that is used to identify where exactly to send the information. Additionally, it's also the job of the data link layer to present the data in a format suitable for transmission. What is the name of this layer? It is data link. What is the name of a piece of hardware that all network devices come with? Do you remember this? The piece of the hardware, a network interface card, or a NIC. So we got layer 1, which is physical, your Ethernet cables. We got layer 2, data link, which is the network interface card, and then is the addressing, focuses on the physical addressing of the transmission. Okay, let's get a network. The third layer of the OSI model, network layer, is where the magic of routing and reassembly of data takes place, from these small chunks to the larger chunk. Firstly, routing simply determines the most optimal path in which these chunks of data should be sent. Whilst some protocols at this layer determine exactly what is the optimal path, we should only know about their existence at the stage of the networking module. Briefly, these protocols include OSPF, Open Shortest Path First, and RIP, Routing Information Protocol. The factors that decide what route is taken is decided by the following. What path is the shortest? Has the least amount of devices that the packet needs to travel across? What path is the most reliable? Have packets been lost on the path before? Which path has the faster physical connection? So one path is using a copper connection or a fiber, which is considerably faster. At this layer, everything is dealt via IP addresses such as this. Devices such as routers capable of delivering packets using IP addresses are known as layer 3 devices because they are capable of working at the third layer of the OSI model. So now you know that your router is a layer 3 device, and layer 3 is called network, which makes sense. And they deal with IP addresses, and they have protocols that kind of or try to determine the best path for the packets. OSPF, Open Shortest Path First, and RIP, Routing Information Protocol. What is the name of this layer? Do you remember? We just checked it. It is network. Good job. Will packets take the most optimal route across a network? I mean, we do literally have protocols right here to determine that. So, yes. What does the acronym OSPF stand for? Do you remember, or should we go back? I can't hear you. Well, of course I can't hear you. We should do something about that. Maybe I should stream these? Nah. Well, if you don't know, Open Shortest Path First. I don't know if you know or not. Path First. What does the acronym RIP stand for? Do you remember, or do you want to check? I cannot hear you. Whatever. Routing Information Protocol. I hope you remember that. So, Routing Information Protocol. What type of addresses are dealt with at this layer? It is IP addresses. Good job. Good job. Do you know what IP stands for? Good job. Internet protocol. Good job. I don't know if you answered that or not, but I'm going to assume that you are a smart and a hard studying dude. So we spoke about 3 layers so far: physical, data link, and network. Physical is your wires. Data link is your MAC addressing and stuff like that. Network is your routers and IP addresses and determining the best path for packets using 2 protocols: OSPF, open shortest path first, and RIP, routing information protocol. Okay. Let's go to layer 4, which is the transport layer. Layer 4 of the OSI model plays a vital part in transmitting data across a network and can be a little bit difficult to grasp. When data is sent between devices, it follows one of 2 different protocols that are decided based upon several factors: TCP and UDP. Now, these ones are very important, so please focus up, because these protocols are going to be pretty important. TCP and UDP. TCP is the transmission control protocol. This is very important to remember. This is very important. If you click on TCP, is a connection-oriented protocol requiring a TCP 3-way handshake to establish a connection. TCP provides reliable data transfer, flow control, and congestion control. Higher level protocols such as HTTP, POP3, IMAP, and SMTP use TCP. TCP is important because it ensures that your data is going to get there in the exact same order you want them to get there. Because, actually, let's continue, because you're going to see the table here. Potentially hinted by the name, this protocol is designed with reliability and guarantee in mind. This protocol reserves a constant connection between the 2 devices for the amount of time it takes for the data to be sent and received. This is why it guarantees it will get there. Not only this, but TCP incorporates error checking into its design. Error checking is how TCP can guarantee that the data is sent from the small chunks in the session layer, layer 5, has been received and reassembled in the same order. Okay? Summarize the advantages. It guarantees the accuracy of data. Disadvantages: requires a reliable connection between the 2 devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. Okay? Capable of synchronizing 2 devices to prevent each other from being flooded with data. A slow connection can bottleneck another device, as the connection will be reserved on the receiving computer the whole time. Performs a lot more processes for reliability. TCP is significantly slower than UDP because more work has to be done by the devices using this protocol. So you're trading accuracy for time and like connection reserving and stuff like that. TCP is used for situations such as file sharing, internet browsing, or sending an email. This usage is because the services require the data to be accurate and complete. No good having half a file, obviously. In the diagram below, we can see how a picture of a cat is broken down into smaller pieces or small pieces of data known as packets from the web server, where the computer reconstructs the picture of the cat into the correct order. So there we go. The first packet is the head, the second packet is the body, the third packet is like the bottom, legs, and tail, and then the computer, on the other hand, just puts these packets together because it knows this is packet 1, this is packet 2, packet 3, and so on. And then it constructs the final image, and then there you go, you have your cat image. This is TCP. Now let's move on to the user datagram protocol, which is UDP. This protocol is not nearly as advanced as its brother, the TCP protocol. It doesn't boast the many features offered by TCP, such as error checking and reliability. In fact, any data that gets sent via UDP is sent to the computer whether it gets there or not. So you're sending it, you're winging it, and if it makes it, it makes it. If it doesn't, then it doesn't. There's no synchronization between the 2 devices or guarantee. Just hope for the best and fingers crossed. This is literally what UDP is. And this is why it is great in streaming. So for example, when you're streaming, you're just sending packets to the server. Let it be, it reaches there or it doesn't reach there. No matter, you're just going to get like a buffer, or you're going to get a drop in the video that you're watching or streaming or whatever. And this is why it is using UDP. One, it's much faster. This is why it's really cool in like calls and like audio calls, video calls over the internet, of course. and why it's cool for streaming and stuff like that, where you care about speed and real time more than about the accuracy of the data. UDP is much faster than TCP. UDP doesn't care if the data is received. UDP leaves the application layer to decide if there's any control over how quickly packets are sent. It is quite flexible to software developers in this sense. UDP does not reserve a continuous connection. This means the unstable connections result in terrible experience for the user. Indeed. So imagining that we are going to send the cat image again, but over UDP instead of TCP, this is probably what you're going to end up with, because packet 2 just failed, and packets fail all the time, by the way. So this is not like the SAT path or the off chance or whatever. This happens all the time, and packets get lost quite frequently. So that's why using UDP is unreliable for things that need to get there and get there in order. UDP is useful in situations where there are small pieces of data being sent. For example, protocols for discovering devices, ARP and DHCP, that we discussed in room 2, which I covered in a previous video. Please go watch that if you haven't. Or larger files such as video streaming, where it is okay if some part of the video is pixelated. Pixels are just lost pieces of data. Now you know. What is the name of this layer? Do you remember, or do we need to go back? I can't hear you. Okay, we need to go back, of course. It is called the transport layer, and it is the 4th layer in the OSI model. Stay up. What does TCP stand for? Do you remember? I'm not gonna look. I'm not gonna help you. Yeah, correct. Transmission Control Protocol. What does UDP stand for? I'm gonna help you. User Datagram Protocol. What protocol guarantees the accuracy of data? TCP, correct. Doesn't care. UDP. What protocol will an application such as an email client use? So if you're sending emails, would you rather your email gets received with only bits and pieces, or would you rather have the entire email being sent? The entire email. Good job. So which one does that? The one that guarantees accuracy of data? TCP. Good job. What protocol will an application that downloads files use? Would you rather have half a file? No, you don't. So then which one guarantees the accuracy and deliverance of data or delivery of data? TCP. Correct. Yes, that is another TCP. Streams video use. So which one would you think? It is UDP. Correct. So we finished layer 4, which is the transport layer. A quick recap: physical, your wires; data link, your MAC addressing; network, your IP addressing and your routers and stuff. Transport is your TCP and UDP. Let's get to the session layer. Once data has been correctly translated or formatted from the presentation layer, layer 6, the session layer will begin to create and maintain the connection to other computer for which the data is destined. When a connection is established, a session is created. Whilst this connection is active, so is the session. The session layer is also responsible for closing the connection if it hasn't been used in a while or if it's lost. Additionally, a session can contain checkpoints, where if data is lost, only the newest pieces of data are required to be sent, saving bandwidth. What is worthy of noting is that sessions are unique, meaning that data cannot travel over different sessions, but in fact, only across each session instead. What is the name of this layer? This is a trick question. What is the technical term for when a connection is successfully established? Do you want to look through that, or do you want me to answer that? Session. Correct. I don't know if you guessed that or not, but it is the same name of the layer. A session is essentially a connection that has been established. This is what a session is. So we got layer 5. Let's go to layer 6, which is the presentation layer. Layer 6 of the OSI model is the layer in which standardization starts to take place, because software developers can develop any software, such as an email client, differently. The data still needs to be handled the same way, no matter how the software works. So when you view your email address, whether you view it on browser, or whether you view it on like a desktop application, or anywhere else, like your phone, for example, mobile phone app, you want the email to be the same. This is why no matter how the software looks, the data still needs to be handled the same way. This layer acts as a translator for data and from the application layer, layer 7. The receiving computer will also understand data sent to a computer in one format, distant in another format. For example, when you send an email, the other user may have another email client to you, but for the contents of the email will still need to display the same. Security features such as data encryption, like HTTPS when visiting a secure site, occur at this layer. What is the name of this layer? Presentation. What is the main purpose that this layer acts as? Standardization. Not standardization. Okay, what is the main purpose? Is in which because software that we can develop in software, but data still needs to be handled the same way. No matter how this layer acts as a translator. So I guess translator, is that what you want to? Yeah, okay. So it is a translator. So this is our presentation layer, layer 6, and the final layer is layer 7. The application layer is the layer that you will be most familiar with. The familiarity is because the application layer is the layer in which protocols and rules are in place to determine should interact with data received. Everyday applications, email clients, browsers or file server browsing, software such as FileZilla provides a friendly graphical user interface or GUI for users to interact with data sent or received. Other protocols include DNS, domain name system, which is how website addresses are translated into IP addresses. Okay, so what is the name? It is the application layer. What is the technical term that's given to the name of software that users interact with? GUI, or graphical user interface. Okay? So if you do not understand the OSI model, that is okay. You do not need to understand every single thing in it, but you need to understand that in order to send and receive data between two different applications or two different computers, you need to follow the OSI model. Because otherwise, this is the handbook, or this is your guide in order to know how you can send data between two different machines. Okay? So physical, your wires, data link, we talked about that. Network, and transport, session, presentation, and application. Cool? Let's play this OSI practical game. Can you escape the OSI dungeon? Climb the levels in the correct order to escape the dungeon and reveal the flag. Can you beat our staff high score of 19 seconds? Okay. So we are in the physical. How do I play? What? The movement sucks, bro. So from the physical, we go to the data link. And then from the data link, we go to, PD or DP, and then we would go to the session. Oh, we failed. Oh, no. Winners don't cheat. Okay, I'm not going to cheat. Okay, so let's go from the physical to the data link, and then to the network. And then from the network, once we have a network, do you want to transport? Or do you want to present? Of course you want to transport. And then from the transportation, you have open a session. And then from the session, you want to present. And then that presentation happens on the application. Boom. Well done. Completed in 31 seconds. OSI dungeon escape. But I actually want to restart. Can I restart? Maybe we can do it faster. Maybe we can beat the staff. We're going to start with physical, data link, network, transport, and session, presentation, application. 17.91. Ooh. Ooh, that is close. All right, one more time. One more time. Let's see. Physical, data link, network. Oh, ooh, I missed it. I missed it. Okay. One more time. This is just for fun, guys. If you want to leave, you can leave. Network. And then transport. Session. Presentation. And then, oh my God. Why do you stop? Oh my God, I missed it, didn't I? 19 seconds, yep. Okay. Less time for real. Physical. Data link. Network. Transport. Session. Presentation. Application. Why did you stop, man? Why did you stop? Come on. Okay, I cannot beat 17 seconds. Maybe they're just faking it. I don't know. Anyway, we got the cool stuff. And then the next video or the next thing will be packets and frames. Stay tuned for that. Thank you for watching. Give me a like, give me a subscribe, give me comments, constructive criticism, bad comments. Give me feedback about these videos. I want to know if you are learning more information from these videos, if you like the way that I present things, the way that I teach. If you think I'm going too fast or too slow or whatever, let me know in the comments below. And thank you for watching, and I will see you in the next one, which is going to be about packets and frames. See ya.